Computer says 10 o'clock. It's time to start. Thank you all for joining today. We will be talking about safety, cybersecurity lifecycle, the overview, part 3. We previously, last 2 months, we did parts 1 and 2, and today we'll be doing part 3. Before we start, just let you know a little bit about Exida. We do have locations. We're a global company, roughly around 100 people, but consulting offices pretty much around the world so that we can support our clients. Various services that we provide consulting services, engineering tools in the way of software, product certification, training. We've developed and published quite a bit of reference material. We also run professional certification of personnel. The text in green are those areas that pertain to cybersecurity where we are involved. My name's Hal Thomas. I'll be walking you through this morning. Got over 40+ years of experience within the process industry, some experience in process control, process safety, and over the last 7-8 years I've had to get heavily involved in cybersecurity as well as the other activities. I currently chair Working Group 9 of the S84 committee that deals with safety instrumented systems, where we're looking at cybersecurity relative to the safety instrumented system and the industrial automated control system. Objectives of this 4-part series that we've developed is to provide cybersecurity lifecycle awareness throughout the entire lifecycle, and in the next part 4, we'd be complementing that with how to get into that life cycle if you happen to be an existing brownfield site that's already in operation. So that's the understand how. We also want you to understand how cybersecurity integrates with both the process safety and the functional safety life cycles that companies have in place already, so that we can minimize the impact and make things as efficient as possible. So today the focus is going to be on the operate and maintain phase of the overall life cycle. Just in the way of review, part 1 talked about the assessment phase or the analysis phase. Part 2 talked about the design and implement phase. Today, the plant has now started up. It's in operations. It needs to be maintained, so we're talking about the operate and maintain phase. You can see from this slide that we've got 2 parallel life cycles, and we do that because there's a lot of activities and tasks that are very specific to whether you're dealing with the traditional process safety or whether you're dealing with cybersecurity that may well impact process safety. And you see those green arrows going back and forth. It shows that we want to integrate those two to the greatest extent possible to leverage work processes that are already in place so as to minimize disruption and maximize understanding. Here's a more detailed view of the operate and maintain phase, where I've already said we've started up, we're in operation. On the subsequent slides, we'll walk through security monitoring and metrics. We'll talk a little bit about some of the things to consider depending upon types of threats that you may be faced with. As you go through this, you need to maintain your cybersecurity countermeasures. And periodically, you need to do a reassessment. As with every process facility, nothing is ever static. There's always the potential that changes may need to be considered, so we will be looking at the management of change. And completion of the life cycle, what would end it would be if you went through decommissioning. And decommissioning can be very, very important, which may require you to invoke the entire life cycle to deal with decommissioning, particularly in those cases where you're only decommissioning a portion of a facility. Because of all the interconnections, all of the interrelationships between various units and plants, one needs to make sure that when you do this, even though you're eliminating some threats by getting rid of a particular operating unit, how you do that might impact other units that continue to be in operation. So let's first look at monitoring and metrics. You can classify the intent of monitoring and metrics as one, to measure the health and the current integrity of the security measures that you have in place. What's the overall integrity of your security? And also, a major intent is, if you happen to be under a cyber attack, identify that you actually are under attack and what are those required responses. Means of measuring: you can do online continuous measurement. You might do periodic online measurements that are batch type activities. You can also supplement with offline periodic inspection and tests. Some examples. Certainly the next few slides of examples is not going to be a rigorous, it's not going to be all-inclusive. It's intended to give you some examples of things that you may want or need to consider. You can look at intrusion detection. You can classify or subdivide that into network intrusion detection systems or host intrusion detection systems. If you're looking at the network, things that you can do are monitor network traffic. If you see a pattern that is not typical, you're going to need to assess whether or not you're under an attack. How important, just what the intent of that attack is will help you determine how to respond to that. You may also have predefined rules that are signature based, that if they're violated, you can then respond to that. A heuristic based approach is to look at communication behaviors. You can also employ passive sniffing or look at inline deployment. When you're looking at the host intrusion, you probably want to be looking at application log files, and depending upon whether you detect someone trying to gain access that's unauthorized, then you want to alert people that that is happening so that you can properly respond. Other examples can include security information and event management systems. These types of systems can use pre-programmed intelligence that are able to detect patterns that come out of seemingly random log events. You've got logs pretty much being created, matter of fact, in a number of devices: servers, routers, switches, firewalls, etc. Not a totally inclusive list. And part of that, implementing a syslog, that's a way to consolidate the information into the log information. That uses a standards-based communication protocol. When you've got these things consolidated, then you can analyze those to determine whether you see somebody trying to be doing things inside your system that are not intended to be done, which allows you then to respond appropriately. Example metrics might include looking at periodic inspections of both physical access versus requirements using a checklist. You may look at the number of failed user access attempts, might look at the number of unauthorized successful user access attempts. If there was a successful unauthorized access, at that point you'd want to have an immediate response to deal with any potential immediate concerns, but then there should be a root cause investigation to see why an unauthorized access was actually successful. You may need to improve or beef up the countermeasures or procedures that you have in place. Other means of identifying unauthorized access things is where you have unauthorized changes in the safety instrumented system that might be discovered during a periodic audit. That would be more of that batch or periodic measurement. Whenever you detect that you have an attack underway, successful or not, based upon what you find, you want to discern what the intent of that attack is. That will help you determine what the appropriate response is. You should have a documented plan in place to help guide that response. If you consider back in phases 1 and 2, the documented plan was supposed to have been actually written down, documented, training provided. It all started out at the high-level cybersecurity risk assessment, where depending upon what device was compromised, you could evaluate what the potential consequences were, and based upon the potential consequences, that could direct you to determining whether you're simply going to isolate and quarantine that device while you continue operating and perform repair, all the way up to, hey, I am seriously compromised. I may have a safety event if I don't take immediate action, and that might entail shutting down the unit until the issues are resolved. And there are a distribution of responses between those two things. Very important to pre-think how you're going to respond to these, why you're going to respond one way versus another, and that will help you maintain a safe and profitable plant over the long run. As part of that documented plan, you need to address backup and recovery should an attack be successful or partially successful. And as I mentioned before, you need adequate training, and the only way you can have adequate training is to start out with a well thought through response plan to begin with, based upon the risk and knowledge of your system and what's supposed to be correct versus what is incorrect. Following up on these attacks, should an attack be successful or partially successful, I had previously mentioned you should be considering root cause investigation. From this, you may identify the need to upgrade countermeasures. We're in a time where the attackers are becoming more sophisticated, the techniques and capabilities are improving, and from a defensive posture, we're playing catch-up. We started out not paying a lot of attention to these things in the process control world. Now we've recognized that they need to be, but as it's an evolving landscape, what were good quality countermeasures yesterday that helped us meet our corporate risk criteria, next month they may be not quite up to snuff, and using this feedback mechanism from attacks and doing that root cause investigation, we can then upgrade our systems accordingly, both to maintain safety and cybersecurity, as well as maintaining an operable plant. In process safety management, they use the term mechanical integrity program. It's not a great term for electronic stuff or cybersecurity countermeasures, but the intent of process safety management is to have maintenance programs, test inspection and test programs for your critical protection or your safety related protection. So your cybersecurity countermeasures, they need to be included in what would be considered either your maintenance or your mechanical integrity program. Some examples, are the people providing you hardware. They're finding flaws in their software, so you end up with patch management in order to, once they discover flaws, they'll go through patch management so that they can upgrade their system to be less susceptible, less vulnerable in the future. As new viruses are written by people who have malintent, the antivirus software is a countermeasure, and they are constantly going through updates that need to be appropriately considered and updated as appropriate. Other countermeasures, number of administrative procedures, number of support work processes. These need to be tested and practiced with plant support personnel present. Using your metrics collection systems, some of those things can be automated, and that provides you some automated diagnostic performance of your system, and based upon how well it is or is not performing can cause you to go in and make improvements if needed. Any deviation should be discussed and resolved if any changes are proposed using your change management practices. And all of that also includes an update of your documentation. If you don't have good solid documentation, then when someone wants to make a change, it's much easier to come up with the wrong conclusion and make mistakes that put you in harm's way. Here's an example of some of the things that you need to be thinking about. This was a malware incident, and the operator of an oil platform realized that they had some SQL vulnerabilities, and they were actively pushing patches out to their HMI and servers on the platforms. They had many cases where patches had been installed, but the systems had not been rebooted due to lack of qualified IT personnel on the platform. As a result, they had during the patching, they had a loss of view and loss of data. And if you take a look at what was going on, it was because the patches that were being put into place were not done according to an appropriate procedure using qualified personnel. So this was more of an operability incident. I'm sure it caused them some real heartburn. while they were going through this, but it illustrates why you need good procedures, you need competent personnel, you need to be doing these things. Otherwise, you can have greater risks result or greater hazards manifest themselves. But when you implement these things, it's got to be implemented properly, recognizing that simply doing these updates improperly can cause their own problems. Here's an example where there was an accidental software failure causing loss of view, loss of data. There was an antivirus update, and it prevented a safety shutdown. There was an approved boiler safety protection system, and it used Microsoft Excel on a PC workstation, personal computer workstation, that was used to interface with the controller to do the programming or configure it. The workstation also had Norton antivirus software running. However, following the update, the antivirus software prevented the proper communication between the PC and the protection system, which is a real problem. Now, updating your antivirus software is very, very important, but how you go through those updates prior to implementing, you need to be doing some some testing to make sure that you're not going to impact your safety instrumented system. You've got to look at all of these issues and not just focus on the antivirus software itself. You've got to look at how it's impacting to make sure it's going to be okay. And if it's not, then you want to go, and it's not a question of, well, it's either antivirus or putting it in or not putting it in. You want to do the updates, but you want to make sure that the antivirus software is going to perform its mission without impacting the safety system or the controls. And the only way you can ensure yourself of that is prior to implementation, go through some appropriate testing to ensure that the antivirus software is ready to go. If it's not, then you get together with the manufacturer of it to make it better. Periodically, just as in the process safety world, where hazard reviews are revalidated, for instance, with cybersecurity, you need to go through a similar type of periodic assessment or revalidation. What's recommended is to perform a vulnerability assessment as a snapshot of where you exist today. A vulnerability assessment basically is looking at how good is your cybersecurity relative to the current state-of-the-art recognized and generally accepted good engineering practice. And as I said before, even though what you put in, say, 5 years ago is still humming along just as it was, it's humming along today just as it was 5 years ago, the landscape may have changed that it no longer complies with RAGAGEP or recognized and generally good accepted engineering practice, because that has moved forward, and you may need to address that. You also may find that some of the countermeasures that you had put into place are not really performing up to the level that they were given credit in the prior risk assessments, and so that would need to be addressed. The advantage here is that you're able to compare real experience against your prior risk assessment and security level verification assumptions. As you gain that real experience, it can go one of two ways. You can find out that in some cases you may have been overly conservative, but in a number of other cases you may have been optimistic with some of your assumptions. Either way, you want to make what you have today commensurate with what your real risk is, so that you can do two things. One, operate as profitably as possible, while at the same time completely satisfying your corporate risk criteria. During this assessment, you want to address any deficiencies found. As part of the assessment, you will go back and revalidate the cybersecurity detailed risk assessment, and if necessary, you may need to go back and make some changes to your security level documentation if you find that anything was insufficient. From a timing perspective, at an absolute minimum, you should be doing this no longer than what is mandated for process safety management, which is generally 5 years around the world. However, considering that changes to the cybersecurity landscape are occurring much more rapidly than the typical traditional safety world, companies may want to look at shorter intervals or have some mechanism to shortchange or short-circuit the interval and initiate it sooner if through your performance measurement you're finding out that you're having problems occur due to successful or partially successful attacks as part of your monitoring and metrics. Now, to facilitate management in phases 1 and 2, we had talked about cybersecurity assessments 1, 2, and 3. These can be looked at as contributions to the functional safety assessments that are required for safety instrumented systems. The stage 4 security assessment occurs in the operate and maintain phase. It happens after gaining experience in both operating and maintenance. This is where you're required to make sure that independent checks of the work have been carried out. It's to validate that work being performed is actually being performed by competent personnel. Things are properly documented and communicated. The overall intent is you want to make sure that assumptions that were made are validated or found out to not be correct. If the assumptions made in the past were not correct, then you want to correct the risk assessments as applicable. Ultimately, you want to make sure that the security levels that you have defined as necessary to meet your corporate risk criteria, that they are being sustained for the life of the facility. As I indicated earlier, management of changes is important. Changes are always being proposed within operating plants due to a variety of reasons. They come from a lot of directions. It is quite important that cybersecurity be integrated into your existing management of change program. If you don't address it with some of the details, then a lot of the people in operating plants, they might not recognize the importance of or potential risk that may occur due to proposed changes that impact the cybersecurity. So you want to make sure that your management of change program has the appropriate people with the appropriate competence levels to be part of the review, both to identify when when a change is potentially impacting cybersecurity so that it can be evaluated properly before implementing that change. Change needs to be evaluated. When you do the evaluation, you want to look at it for its impact versus your process safety information. You want to look at it for the impact versus the assumptions made in the cybersecurity lifecycle. Go back to the cybersecurity requirement specification that concluded the analysis phase of the life cycle. We talked about that in part 1. You may need to go back to the cyber risk assessments, either the high level or the detailed cyber risk assessment, to see if a change is going to impact your risk from a corporate tolerability perspective. You also have whatever documentation you had that made you feel comfortable that the security level that you defined as necessary is being met, the security level verification. Go back to those assumptions. You may need to look at the product supplier's safety or cybersecurity manuals. And you also want to look at things versus the business network integration agreements and policies. So there's a lot of stuff to look at. You need folks who understand these things, who are competent in these things, to be part of that management of change work process. The Stage 5 cybersecurity assessment, this happens basically prior to decommissioning. You want to, here the intent is to make sure that you've got a robust management of change procedure program in place that adequately addresses and includes cybersecurity. Once again, it's there so that you help ensure that you're sustaining the security levels that you need for the life of the facility. And as in all of these things, it needs to be an independent check. It needs to be done by competent personnel, and you need proper documentation, and results need to be communicated to folks so that if there's any deficiencies, they can be addressed and corrected. Decommissioning itself, oftentimes you really should consider a complete safety life cycle approach to decommissioning, going through each phase: analysis, design and implementation, and then you're not going to really operate and maintain. However, you are going to execute the engineering and implementation phase, and you may very well have continued operation of other facilities that you want to make sure are not negatively impacted. In all cases, a decommissioning plan should be developed. You need to include all the plant personnel that are familiar with the facility. From a functional discipline perspective, that would include operating personnel, maintenance personnel, management personnel, appropriate engineering personnel that would include controls, also IT personnel, safety personnel. All of these folks are going to have an input into the planning. It's very difficult for one or two people to appreciate all the things that can happen, so it really needs to be a teamwork exercise. A key piece of information, your life cycle should be making sure that you're maintaining all of your documentation up to date. Okay, that's just an absolute expectation. Unfortunately, in the real world, that is an area where companies struggle with. But whenever you're going into something like this or a new project, you need to make sure that all your as-built information is not only available, but that it is correct before proceeding with any and all aspects of decommissioning. So, in part 3, the operate and maintain phase, we looked at various examples of cybersecurity monitoring and metrics. Based upon what you find, you need to have appropriate responses documented that can be put into place to help guide that response. We also talked about the maintenance and mechanical integrity program, which think of as your countermeasure inspection, testing, and maintenance to ensure that they continue to be, your countermeasures continue to be robust and capable of sustaining cybersecurity for the life of the facility. Periodic assessments are necessary. Vulnerability assessment is a key kickoff point to that overall periodic assessment. We also touched upon the importance of including cybersecurity into your management of change program, and then we talked about decommissioning and the need oftentimes to apply the full life cycle to a decommissioning project. So that concludes my presentation, but we now can entertain questions that folks may have. Okay, my apologies for displaying my email. I did not know that was happening. And I'm told that, let's see, why, I'm assuming that sound actually got there. Okay, we've got a question. I don't wish to group maintenance and mechanical integrity, as the latter is an OSHA auditable containment program. This is important but kept separately. Answer to that is OSHA PSM talks about the need to address in your mechanical integrity program all your safety controls, alarms, and interlocks. Once you've got cybersecurity that is potentially impacting process safety, then per PSM, mechanical integrity would be an appropriate term. If a company wishes to simply call it maintenance, and that's how they plan to comply with various regulations, that is up to specific companies. Is there, do we have any additional questions? If there are no additional questions at this point, I'd like to thank everyone. If you happen to think of questions, okay, we got another question. Why not a greater emphasis on whitelisting? As I said, the examples were not an inclusive list. It was just to get your thought process going. Certainly whitelisting is a countermeasure that could and should be given consideration. What we basically said in the parts 1 and 2, particularly when you're doing the analysis, phase of the life cycle, you're identifying hazards, potential hazards, and you are deciding upon what security levels you need to be trying to attain. And just as in the safety world, you take a look at your countermeasures relative to a specific hazard that may exist. In the world of cybersecurity, there are a great variety of threat vectors that may come into play. And not all countermeasures provide protection against every threat vector. So each threat vector needs to be looked at independently during that analysis phase. You take a look at what countermeasures that you have in place, make an evaluation as to whether you're meeting your risk criteria or not. And if you're not, then you're going to look at countermeasures that are both effective. They actually need to have some hope of working for that specific threat vector. Simply having 7 countermeasures does not necessarily give you defense in depth, because you may, if things are easy, you may have a whole lot of countermeasures that protect against a fairly simple thing to defend against. Something that is a little bit more difficult to defend against, you may have less countermeasures, all the way down to no countermeasures. So certainly whitelisting in the context of the appropriate threat vector would be one of those things that can and potentially would be considered to determine whether you are or are not meeting your corporate risk criteria. So, okay, another person joined a little bit late. He's indicating, can I open the webinar again to review it? Yes, you should be able to access the webinar online and actually review the webinar again, or if you missed it, then on your own you should be able to access the webinar. Okay, any other questions we may have here? Before I sign off, if you think of a question later, or later today, tomorrow, next week, feel free to just go on to our website, send in, document the question, send it in, and we will respond as best we can. So, with that, I'd like to thank everyone and look forward to talking to you all again in a month or so when we deal with part 4. Have a nice day. Oops, okay, something. All right, just a comment, no question. All righty, thank you much.